the CPU, which stands for Central Processing Unit. It is the brain of the computer. But this idea didn't start with Intel or AMD. It started more than 70 years ago. The idea of a CPU began in the 1940s, when early computers were massive machines that filled entire rooms. At that time, computers didn't have a single chip doing all the thinking. The foundation was introduced by John von Neumann, who proposed a model where a computer could store instructions and process them step by step. This idea became the base of modern computing. Years later, in 1971, Intel released the Intel 4004, the first commercial microprocessor. For the first time, the brain of a computer was placed onto a single chip. That moment changed everything. From that point on, the CPU became the central decision maker. Every instruction, opening an app, calculating numbers, or rendering graphics, passes through it. As the industry grew, two major players emerged, Intel and AMD. They didn't start at the same time, and their history explains a lot about how they design CPUs today. Intel was founded in 1968 by Gordon Moore and Robert Noyce, two pioneers of modern computing. Intel focused early on building powerful processors for personal computers and businesses. AMD came 1 year later, in 1969, founded by Jerry Sanders. AMD's goal was to challenge Intel by offering efficient and affordable alternatives. Over time, both companies created their own CPU families. Intel introduced the Core series, Core i3, i5, i7, and i9, with newer generations improving speed and efficiency. Today, Intel's latest designs appear in modern Core i series and Core Ultra CPUs. AMD answered with Ryzen 3, 5, 7, and 9, focusing on strong multi-core performance and better power efficiency. Their newest CPUs come from the Ryzen 7000 series and newer generations. So when you compare an Intel Core i7 and an AMD Ryzen 7, you're not just comparing brands. You're comparing decades of different design philosophies, improved generation by generation. Intel usually focuses on making each core very strong, so everyday tasks feel fast and responsive. AMD often focuses on adding more cores and using power more efficiently, which helps with multitasking and heavy workloads. Neither is automatically better. The better CPU is the one that matches what you do every day. So how does a CPU actually work? Inside the CPU, there are cores. Each core acts like a mini brain. More cores help the computer handle multiple tasks at the same time. That's why web browsing uses fewer cores. Editing, coding, and gaming use more cores. The CPU works in a continuous cycle. First, it fetches instructions from memory. Then it decodes them, meaning it understands what to do. Finally, it executes them and sends the results back to the screen or other parts of the system. This cycle repeats billions of times every second. As software became more complex, engineers realized that one processing unit wasn't enough. So, CPUs evolved to include multiple cores. Each core acts like an independent worker. More cores allow a computer to handle many tasks smoothly, running browsers, code editors, and background processes at the same time. But here's where many people get confused. Performance isn't only about adding more cores. Speed matters too. You'll see numbers like 3.2 GHz or 4.5 GHz. This shows how fast a CPU runs. Higher speed means faster reactions. But speed alone doesn't tell the full story. Two CPUs can run at the same clock speed, measured in gigahertz, yet one can still feel much faster than the other. That's because real performance is not just about speed. It's about efficiency. Think of it like two people working for 1 hour. If one finishes more work in that same time, they are more efficient, even if both move at the same speed. Modern CPUs are designed to work smarter, not just faster. They can complete more instructions in each clock cycle, which means they do more work without needing higher gigahertz numbers. This improvement usually comes with newer CPU generations. Each generation brings better design, better instruction handling, and smarter power usage. That's why a newer mid-range CPU can outperform an older high-end one. So when you compare a 2017 Core i7 with a 2023 Core i5, the newer i5 often wins. Not because of the name, but because it belongs to a newer generation with better design, better efficiency, and better use of power. So how do you know which generation a CPU belongs to? For Intel, the generation is hidden in the model number. Take Core i7-10700 as an example. The first two digits, 10, mean it's a 10th generation CPU. For i5-13400, the 13 means 13th generation. The bigger the number, the newer the design. For AMD Ryzen, it works in a similar way. In Ryzen 5 3600, the first number, 3, means 3rd generation. In Ryzen 7 5800, the 5 shows its 5th generation. Newer models like Ryzen 7 7700 belong to newer generations with better efficiency and performance. So instead of only looking at names like i7 or Ryzen 7, always look at the numbers after the name. That's where the real story of performance is written.